Everyone, it's Linden, and I'm here to talk about problem 10 from the sprint round of test 12311. And this problem reads, triangle ABC has AB equals 80, BC equals 80, and angle BAC equals 75 degrees. Triangle A prime, B prime, C prime is formed by translating triangle ABC such that B prime is the midpoint of AC. If lines BC and A prime, B prime intersect at X, how many degrees are in the measure of angle A prime XC? So the first thing we should do is we should draw ourselves a diagram. And so I will draw a triangle that looks like this. And this triangle is going to be triangle ABC, where AB equals 80, BC equals 80, and angle BAC equals 75. So as you see, it looks something like this, where this angle is 75. Now we take this triangle and we translate it down, we shift it down such that B prime is the midpoint of AC. So B prime would be about here, and our translated triangle would look something like this. Apologies if this is not perfect, but anyway, this is B prime, or A prime is going to be here, C prime is going to be here, and this angle is going to be 75 as well, because translating a triangle does not change the angles in any way, shape, or form. And what we are asked is, let's say that lines BC and A prime B prime intersect at X. So if I extend A prime B prime, and then we'll color this red. If I extend A prime B prime to meet line BC at this point over here, X, we want to figure out how many degrees are in the measure of angle A prime XC, which is this angle over here. And I'll mark this with green. That's what we're trying to find. So how are we going to go about doing this problem? Well, first of all, it would be very nice to maybe figure out other angles that are similar to this angle, because what we have when we translate this triangle downwards is we get a bunch of parallel lines. And the reason I say parallel lines is because translating a triangle does not rotate it, does not reflect it in any way, shape, or form. So, for example, line AB is parallel to line A prime B prime. Any line in general, if I shift it over, just move it right, the new line is going to be parallel to the old line, right? But if I were to take this line, move it over here, the new line would be parallel to the old line. And therefore, this side is parallel to this side. This side over here is parallel to this side. And then AC is parallel to A prime C prime. And the reason we like parallel lines is because they allow us to look at a lot of equal angles. For example, if I have two parallel lines over here and then a third line intersects these two parallel lines, then this angle over here is going to be equal to this angle over here. We call this a transversal parallel lines. That's also equal to this angle over here and this angle over here. And that's going to be very, very useful to us in this problem, because this green angle right here, if you look at line A prime X, this green over here is formed by that line and BC, but BC is parallel to B prime C prime, and therefore we have the same transversal over here. And because of that, this angle is the same as this angle. But you can look even further and say, hey, well, this triangle A prime, B prime, C prime is just triangle ABC, but translated, and translating a triangle does not change its angles because we just moved it over. And therefore, this green angle over here should be equal to this green angle over here. And now all we have to do is figure out the measure of this angle over here in triangle ABC, and we'll be all set. So how do we do that? Well, if you're a bit stuck, you might look back at the problem statement, and in general, this is a very good strategy. If you get stuck, look at the problem statement and try to pick out information that you haven't used yet. And in this case, we haven't used the fact that AB equals 80 and BC equals 80. So I go ahead and I'll do this in maybe blue. This side is 80, and so is this side. BC is also 80. And well, what does that tell us about angles? It may not be immediately obvious, but let me show you one last theorem that I learned a little while back, where if you have an isosceles triangle, like this one over here, no matter like how long the sides are, if this triangle is isosceles and this side is equal to this side, then this angle is equal to this angle because this angle is across from that side and this angle is across from that side. And you can prove that if you want to. One of my old teachers called this the Bob's theorem, bigger angles across from bigger sides. And we're going to use that to make progress on this problem, because as you see, a triangle ABC is isosceles with AB equals 80 and BC equals 80. And so if you look at the two angles across from these two sides, they should be equal to each other, which means that this angle over here should be 75 degrees as well. And because the angles of a triangle add up to 180 degrees, this green angle should be equal to 180 minus 75 minus 75, which is 30 degrees. And so our final answer is 30. That's it for this problem. Thank you for watching, and we'll see you next time.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.